are physics power leaders from KHONG. Today we are going to introduce about the subtopic of chapter 3, which is KHONG rule. My name is THENG from MD32, and these three girls are my partner today. So let them introduce themselves right now.
Hi, my name is KHONG from MS28.
Hi, my name is CHEI from MS24.
Hi, my name is Emily from MD21.
Let us start!
Let me introduce about KHONG rule. So, what is KHONG rule? KHONG rule is a pair or set of rules or laws which deal with the conversions of current and energy within electrical circuits. These two rules are commonly known as KHONG circuit laws and KHONG voltage law. The first is KHONG's current law. The KHONG current law states that the total current or charge entering a junction or node is exactly equal to the charge leaving the node, as it has no other place to go except to leave, as no charge is lost within the node. In other words, the algebraic sum of all the currents entering and leaving a node must be equal to 0. The second law is KHONG voltage law. Starting at any point in the loop, continue in the same direction, noting the direction of all the voltage drops, either positive or negative, and returning back to the same starting point. It is important to maintain the same direction, either clockwise or anti-clockwise, or the final voltage sum will not be equal to 0. After knowing about the theory of KHONG rule, let us move to some example questions to let you know more. Click the link inside the description box to get our questions.
Okay, when you see the question is present of two loops and a few junctions, like junction 1 and junction 2, you can just use the KHONG rule. The upside here is one loop consists of one battery and two resistors. And the bottom one, there is one loop consists of one battery and two resistors. Take note here, the 18 ohm resistor at the middle one actually is involving in both loops. Means when we use the KHONG second rule to calculate the current in loop 1 and loop 2, the 18 ohm must be considered in both calculations. Let us try to answer the question. It wants to find the current through the 12 ohm resistor. So we look at the figure there. That is I1. The current flows the 12 ohm resistor. First of all, according to KHONG first rule, the total of current flows in a junction is equal to the total of current flows out a junction. This is in and this is out. Okay, in the figure here, there are two junctions, which is junction 1 and junction 2. The right side here, there are I1 flows in a junction and I2 and I3 flows out a junction. So we can write an equation. I1 is equal to I2 plus I3. That is the first equation. Let us proceed to another junction, the upside here. There are I2 and I3 flows in a junction and I1 flows out a junction. So the equation is I2 plus I3 equal to I1. This side is in and this side is out. You can realize that the first equation and the second equation actually is same. So we just consider as one equation, I1 minus I2 minus I3 equals to 0. This is the first equation. Then, according to the KHONG second rule, the total of E the total of EMF is equal to the total of IR. So this is first loop, this is second loop. In the first loop, there is only one battery which has the voltage of 6 volt, and I1 pass through the 12 ohm resistor and I2 pass through the 18 volt ohm resistor. So the equation for loop 1 should be positive 6, this is EMF, equals to 12 ohm multiplied with positive I1 plus 18 ohm multiplied with positive I2. Then this is, we simply simplify the equation. 6 is equal to 12 I1 plus 18 I2. So 1 is equal to 2 I1 plus 3 I2. This is second equation. You can realize that all the sign for the second equation is positive. This is because the direction of the loop 1 actually is same to the flows of current, which is clockwise direction. Okay, let us proceed to the second loop. The direction of the loop is anti-clockwise. Here, anti-clockwise, but you can realize the I3 is flow opposite to the direction of loops. So the sign of I3 actually is negative. The total of EMF for loop 2 is 9 volt, positive 9 volt, because this is the same direction to the loop, and in the loop 2 is only one battery. So the equation should be positive 9 equal to 18 ohm multiplied with positive I2 plus 8 ohm multiplied with negative I3. So the equation is 18 I2 minus 8 I3 equals to 9. This is the third equation. Then we rearrange the equation we find just now. The first equation is I1 minus I2 minus I3 equals to 0. Then the second one is 2I1 plus 3I2 plus 0I3 equals to 1. This is 0 because there is no I3 in first loop. So we just write down 0. And the third equation, 0I1 plus 18 I2 minus 8 I3 equals to 9. Then we simply substitute these values into the calculator. We choose the simultaneous equation function with 3 unknowns, and lastly we will get I1 equals to negative 0.013 ampere, I2 is equal to positive 0.342 ampere, I3 is equal to 0.355 ampere. Is it the final answer? No, because the equation is because the question is to find the I1 only. You can look at the question. You want to find the current through the 12 ohm resistor, so it's only I1. Then lastly, we can just do the conclusion. I1 is equal to 0.013 ampere to the left. Because the sign is negative, so it to the left. Okay, thank you. That's all.
Now we look at the second question. The second question says that calculate the current I1, I2, and I3 when switch S is open. So we can see when this switch S is open, so the loop is not complete. So the I3 will equal to 0. So then the I1 and I2 will equal to I. This is because the I1 and I2 connect in series. Then so the I1 will equal to I2 equal to I. Then the I3 will equal to 0. So this is the first answer. So if the I1 and I2 connect in parallel, the I total will equal to I1 plus I2. Then we look at the second question when the switch S is closed. So we can use the loop. So the loop we can identify the loop is anti-clockwise or clockwise. So the loop, this is the loop 1, this is the loop 2. So we can loop 1, we can use we can identify the voltage first, the direction of voltage first. So the 7 volt is follow downward, then the 6 volt is follow to the right. Then we can use the anti-clockwise. This because can more easily to solve the question. So the loop 1 is anti-clockwise. So the loop is total EMF will equal to total IR. So the total EMF is this 7 plus this 6. Then it's no need to put the negative because the 7 and 6 volt is follow the direction. So it's 7 plus 6 equal this is we need to find the I1 and also the I3. Then the I1 is along this direction, so it's 3 I1 then plus 4 I3, and then no need to put the negative because it follow the direction. So it's 4 I3. So 3 I1 plus 4 I3 equal to the 13. This is the first equation. The second equation, we can also use the loop. Then we can identify the direction first. The 5 volt is go to the upward and the 6 is follow to the right. Then the loop 2, we can use the clockwise. This more easily to solve the answer. So the loop 2 is clockwise. Then the total EMF equal to total IR. Total EMF is 5 plus 6 equal to, we can see this the I1, so it's 3 I1. So it's 3 I1 plus, then we can see this I2. So the I2 is along this wire, so it's need to 1 ohm plus the 2 ohm. So it's 1 plus 2 I2. So it's 3 I1 plus 3 I2 equal to 11. This is the second equation. Then how we need to find the third equation? We can use the junction rule. The junction rule, we can use this junction. This is because more can see clearly the direction of the I1, I2, and I3. So the junction rule is total I input equal to total I output. So we can see the I1 is go inside the junction, so the I1 will equal to I2 and I3. This is because I2 and I3 is go out from the junction. So the third equation is I1 minus I2 minus I3 equal to 0. This is the second equation. So we can use these three equations to find the answer. So the answer will become I1 equal to 2.52 ampere and the I2 equal to 1.15 ampere. Then the I3 equal to 1.36 ampere. So this is our answer. Thank you.
So this question we need to calculate current I3 for the circuit. So we just divide the circuit into two loops first. So for this first loop, we draw it as anti-clockwise. And the second loop we draw it as clockwise. So we just remind back for the first rule of the Kirchhoff rule, which is Kirchhoff current rule, and then the total of the existing current and entering current must equal to 0. So from these questions, the directions of I1 and I2 is already given by the questions, and then we need to find the direction of I3. So for the loop that we draw, we can see the I3 is moving upward, and then we just choose one of the node, either this one or this one, and then we just choose this one. And from this node, we can see the I1 and I2 is entering and pass through this node, but the I3 is exiting from this node. So we can write our first equation, which is I1 plus I2 minus I3 equal to 0. And after that, we look to the first loop. The first loop is anti-clockwise, and then we use the formula EMF equal to IR. And then we can see the factory in this first loop is same direction with the loop, which is anti-clockwise. So all of this EMF is positive. So 4 plus 6 equal to, and in the I1 we can see the I1 has passed through the 7 ohm, so it is 7 I1, and in I3 we can see that it does not have any resistor, so it is 0 I3. This is our second formula, second equation. And from the second loop, it is clockwise, and we also use the EMF equal to IR. And in this second loop, the EMF is 8 plus 4. And the I2, we can see that it passed through the 5 ohm resistor, which is 5 I2 plus 0 I3. And then we can get our third equations, which is 12 equal to 5 I2 plus 0 I3. And then we can get our three equations, and from this we can see the I3 is 0, so we can cancel it, and then we just calculate the I1 and I2. The I1 is 10 over 7, which is 1.43 ampere, and I2 12 over 5, which is 2.4 ampere. And after we get I1 and I2, we can sub it into our first equations, which is 1.43 plus 2.4 minus I3 equal to 0. So our I3 is 3.83 ampere.
Let us look at the last question. Measuring P with EMF 1.3 volt and internal resistance 2 ohm. For measuring Q with EMF 1.5 volt and internal resistance 0.8 ohm and a 4 ohm resistor are connected in parallel. Get the circuit diagram. We know that we have two batteries. This is one P and this is Q. One battery P is 1.2 volt and 2 ohm, and battery Q is 1.5 volt and 0.8 ohm. And we connect together. And there is a 4 ohm resistor are connected in parallel. So we draw in the middle of the circuit. Here is 4 ohm. Then we label the current. This is our junction. So we have current in and current out. For this we can label I1 and current out we label I2 and I3. And look at the second question. Calculate the current between P, between Q and the 4 ohm resistor. And then we can use the KHONG rule. This is KHONG rule, which is junction rule. For current I in equal to current out. So we know that the current in is I1 and current out is I2 and I3. So I1 equal to I2 plus I3. And we can form the first equation, which is I1 minus I2 minus I3 equal to 0. This is our first equation. And then we can use the second KHONG rule, which is loop rule. And we draw the loop first. This is our first loop, and this is second loop. And we can draw either clockwise or anti-clockwise. And then I draw it. For loop 1 I draw anti-clockwise and loop 2 I draw clockwise. Then for loop 1, the total of EMF is equal to total IR. So for loop 1, our EMF is 1.3 equal to, for I1 we have 2 ohm. So it's 2 I1 plus I2 is 4 ohm. So it's 4 I2. This is our second equation. And then for loop 2, our EMF is 1.9 and for I2 is 4 ohm and I3 is 0.8 ohm. So 1.9 equal to 4 I2, but for I3 is opposite direction with the loop direction. So we use the negative 0.8 I3. And this is our third equation. So now we have formed three equations. I1 minus I2 minus I3 equal to 0, and 2I1 plus 4I2 equal to 1.3, and 4I2 minus 0.8 I3 equal to 1.9. And then we can use the calculator to write the current. I1 is equal to 0.019 ampere, I2 equal to 0.31 ampere, and I3 equal to negative 0.297 ampere. For negative is mean that the direction is opposite. And then we know that the I1 is for measuring P, I2 is for ohm resistor, and I3 is for measuring Q. And we can write again that P equal to 0.019 ampere, IQ equal to negative 0.297 ampere, and I resistor equal to 0.31 ampere. This is our answer. For question 3, calculate the potential difference across the 4 ohm resistor. And we know that our resistance is 4 ohm and the current is 0.39 ampere. Or we can use the formula EMF equal to IR, and then 0.31 is multiplied volt, and we can get the 1.2 is volt, and this is our potential difference. Okay, thank you.
That's all for today. Thank you for watching. Bye!